The damage from the storm was severe, but no one was killed because this town knew what to expect. The weather is our biggest fluid system. The only way we can accurately predict it is by measuring its action. Some people can do it by instinct, but the professionals use fluid transducers. Fluid transducers take fluid energy and translate it into some kind of output signal, usually the mechanical movement of a needle or an electric current. Most often, fluids are flowing inside pipes and tubes, usually out of sight. Transducers sense the conditions of the fluids and represent them in a readable form for the technician or the operator. In most fluid systems, pressure and flow rate are the important parameters to be measured. Let's look first at pressure. Changes in pressure are responsible for foul weather, such as a hurricane, which is extremely low pressure. A pressure transducer is one of the instruments used to measure it, the barometer. A barometer uses a partially evacuated chamber with a flexible top. As the atmospheric pressure changes, the top rises or falls. A needle attached to the top of the chamber amplifies the movement and draws it out on a graph. A changing fluid pressure has been translated into the mechanical action of the needle. In the overview program, we saw an automated injection molding machine that made plastic key rings. The machine used a suction system to pick up the parts and move them around. Pressure transducers fed signals to the central controller about the changing pressures in the lines. This is how it could tell whether a part had been picked up. The second half of that process, the assembly, was performed by robots that also use pressure transducers to control and monitor their actions. The robot actions are all driven pneumatically by compressed air. Pressure transducers on the airlines tell the controller whether the robot has picked up a part and whether it has moved to the correct position. It can even tell if the robot has run into something. Pressure transducers are also used for quality control and ensure that rejects are discarded. The transducers are the senses for the system to make sure quality standards are maintained. The other parameter that needs to be measured in fluid systems is flow rate. One way of doing that is to use a mechanical device like a gas meter. The gas alternately fills and empties a bellows. The action of the bellows is used to drive a gear mechanism attached to the gauges. This type of system is fine for low flow rates, but for higher speed flow rates, a different instrument is used called a turbine flow meter. The instrument looks much like a turbine generator because it fits inside the pipe and its blades are spun by the moving fluid. If it was a generator, it would take energy away from the fluid by converting it into electricity. But this is a disturbance because the fluid slows down. The object of a transducer is to measure the flow, not interfere with it. So the blades of a turbine spin freely. To measure its speed, a small coil is mounted outside the pipe. The free-spinning turbine contains a magnet, which produces short pulses of current in the coil on each turn. The rate of the pulses is related to the speed of the blades, which are driven by the speed of the fluid. A fluid flow rate has been turned into an electric signal. Fluid transducers provide valuable information about the condition of fluids inside pipes and tubes. Information the technician uses to operate and maintain the equipment. The signals from transducers are often compared to reference signals stored in central controllers, so they can monitor operations and sense emergencies. You can't tell what's inside a pipe or a boiler just by looking at it. Transducers let you see the invisible, hopefully long before it becomes visible.